Good morning all of you. We are doing physics class 9 chapter number 12. Today we will start chapter 12, thermionic emission and radioactivity. So what do you know about thermionic emission and radioactivity? And this falls in modern physics. Okay. So as we know, atoms of all elements contains a positively charged nucleus and electrons revolving around it in various orbits. In metals, the inner electrons are bound to the nucleus with stronger attractive force, whereas electrons in the outermost orbit, called valence electrons, are weakly held to the remaining parts of the atom, called kernel. As we know that the electrons nucleus, then these are the orbits, eight, 16, and here we find that the elements with exhibits here, they are valence electrons. Why they are valence? Because they doesn't contain all these 16 elements. Sometimes they contains 2, sometimes they contains 4, sometimes they contains 15. Okay, that is why they remains, some of the elements remains valence. In addition, electrons of metals have vacant orbitals in their valency shells. As these orbitals lies very close to each other, the valency electrons in metals get completely delocalized, that is able to move freely around all the kernels. Okay, now what is meant by the term function of metal? So here function of metals we will read. We have seen that electrons require energy to escape from the surface of the metal. The minimum amount of energy required to emit electrons from the surface of metal is known as work function. So this is work function. And what is emission of electrons? It is due to this attractive force which the kernel exerts in electrons, that the electrons are not able to leave the crystal lattice of their own. This attractive force thus acts as a barrier for the electrons. When sufficient energy is given to the metals, electrons are able to overcome the force of attraction and leave the surface. This is called electron emission or emission of electrons. And what is work function? The minimum amount of energy required to emit electrons from the surface of metal is called work function. Okay, so work function is the minimum amount of energy required to emit electrons from a metal. Suppose that an electron, a metal is there, and some electrons want to emit from it. So they require some energy, and that energy is known as work function of that metal. And the work function is denoted by the Greek letter phi, phi, and it is denoted by 0 and this phi. It is generally expressed in electron volt, that is small eV, and it is its unit. The value of work function depends on the nature of the metal, purity of the metal. Different metals have different value of work function. The values of work function are for certain metals are given here in this table. So you have to go through the table. The metals from which electrons can be ejected easily are called electron emitters. So what are electron emitters? The metals from which electrons can be ejected easily, that means it's run away easily, is known as electron emitter. Now we will see some work functions of some metals. Platinum is 6.2, tungsten is 4.52. Similarly, we will see that tungsten coated with the cesium oxide is 1.4. Okay. So there are different types of electron emissions are there. So what are these? These are thermionic emission, photoelectric emission and field emission. Now here we will read about thermionic emission. So what is thermionic emission and how it happens? Now the emission of electrons from any metal when it is heated to a high temperature near about 2500 Kelvin is called thermionic emission. The electrons emitted from a metal when it is heated to a high temperature are called thermions. Okay, they are also known as thermions. So here the thermionic emission, the emission of electrons from a metal surface when heated to which temperature? Heated to nearly 2500 Kelvin are known as thermionic emission. Now we have to go through one activity, that means experiment, which was done by Edison. Edison, in which year? In the year 1883, was the first to discover the emission of electrons from a hot filament. He has discovered that the electrons are emitted from a hot filament. Edison, so how did he use this? How did he concluded that the electrons are emitted? He has done one experiment. Edison used an evacuated bulb having two filaments. See here. It is having two filaments, A and B. Okay. Now the experimental setup is shown here. You can see this. Filament A is connected to a battery. Here A is connected to this battery. Filament B is connected to the same battery through a two-way key and a galvanometer. Two-way key and a galvanometer. The filament B can be made positive or negative with respect to a filament A by inserting keys to the gap A or gap B respectively. Now we will see the observation. What is the observation? The following observations were made from this experiment. When the filament B is made positive with respect to filament A, that means hot carbon filament, current flows through the circuit, that is galvanometer shows deflection. This one shows deflection, that means it deflects from there to there. Okay. Now when the filament B is made negative with respect to filament A, no current flows through the circuit, that is galvanometer shows no deflection. This one shows no deflection. Now, so what is the conclusion after this? From this result we may come to the conclusion that the flow of current through the circuit indicates that the charged particles are able to move across the empty space between two filaments, since the current flows only when the filament B is positive with respect to filament A. Hence, the particles emitted from filament A should be negatively charged. Okay. Now, after the discovery of electrons by Sir J.J. Thomson, the particles emitted from the filament A were called thermions, that is, electrons with emitted to a high energy. The process of electron emission from a hot filament or surface are given the name thermionic emission. Now, what are the factors affecting the rate of thermionic emissions? There should be a factors. Now, the number of electrons emitted by a hot metal surface per second is called the rate of emission. So, what would be the formula? Rate of emission is equals to number of electrons or thermions emitted by time in second. So, rate of emission is equals to number of electrons emitted by time in second. Okay. Now, the rate of thermionic emission depends upon the following factor: nature of the metal. The rate of the thermionic emission is inversely proportional to the work function of the metal. So, the metals having lower work function will have higher rate of thermionic emission, and temperature of the metal surface and surface of the metal. So, what are the requisites for a good electron emitter? To obtain a good supply of electrons, that is metal, to act as a good electrons emitter, it should have the following character. What are the characters? It should have high melting point. Okay, it should have high melting point, and it should have low work function. So, some of the good electron emitters are tungsten, thoriated tungsten, tungsten coated with barium oxide, strontium and strontium oxide. And we have to know what are the various types of electron emitters. There are two types of electron: directly heated electron emitters and indirectly heated electron emitters. So, we will read about hot cathode ray. So, what is hot cathode ray? Hot cathode ray tube is a device that converts electrical signals into visual signals. So, this device, this hot cathode ray is a device which transmits electrical signals into visual signals. Now, so there should be a principle of hot cathode ray tube. Therefore, the principle is: number 1, thermionic emission from a suitable cathode, deflection of the electron beam by rapidly changing electric and magnetic field, production of fluorescence when electron beam strikes a fluorescent screen. Now, what is the design and construction of and working of a hot cathode ray? Now, we will read about the design, working, function of this hot cathode ray. A hot cathode ray tube consists of the following main components: a hollow evacuated glass tube. This one is full hollow. Now, an electron gun. This electron gun. Then deflecting system. This deflecting system. Fluorescent screen. Here, fluorescent screen. Okay. Now we will read descriptively about the electron gun. So, what is an electron gun? It consists of the following components: cathode. It is small filament of tungsten coated with a mixture of barium and strontium oxide. The cathode ray is heated with the help of a heating coil of tungsten connected to a low tension power supply. The cathode emits electrons when heated. Now disc anode plate. The electrons emitted from the cathode passes through two disc anode plates A1 and A2. Having hole at the center. These anodes are raised to a very high positive potential by connecting them to a high tension power supply. The emitted electrons when passes through these anodes get focused and accelerated and comes out of the hole as a fine beam of the electrons. Now deflecting system. The deflecting system consists of two sets of deflecting plates, the vertical set of plate and the horizontal set of plate. Now we will read about fluorescent screen. The broader end of the tube is the shape of a screen. It is coated from inside with the fluorescent material. When the beam of electrons falls over it, a bright spot is produced. The brightness of the spot depends upon the velocity of electrons. The color of the spot depends upon the fluorescent material. For example, soda glass gives greenish color and cadmium and calcium gives bluish color. And what are the uses of this cathode ray? Cathode ray tube is used in television systems. We have seen nowadays we are not able to say because we are using LED tube or LED TV or LCD TV. In previous time, more than 10 to 15 years ago, there would be a cathode ray tube, that is the TV, the dabba TV, whatever you are telling right now is dabba TV. As an oscilloscope, a scientist instrument for studying the waves from the electrical signals in radar systems to measure the short interval of time, to determine the unknown frequency of alternating potential by applying it on a pair of deflecting surface, to investigate the waves from the unknown alternating potential by applying it on the Y plates and known periodic disk potential on the X plates. Okay, so here some examples are given, so you have to go through this. These are very useful examples given over here. You should go through this and you have to do this exercise number 12A. Okay, so 12A you have to complete. Next day we will start from atomic structure and radioactivity. Okay, next day we will start from here 12.4, page number 279. So do this exercise number 12A at your home. Next day we will start from the another exercise. Okay, till then, thank you. Goodbye.